All right, let's check out some of these more trig integrals today that are most likely going to involve some of these identities. All right, we got 3 more to go over, and then I think the best thing to do is just practice, practice, practice. So maybe we can go over some homework ones together. I can give you some time to do them on your own, whatever floats your boat, okay? All right, so take a look at 6. What do we feel like doing for 6? Again, besides crying. No. Yeah, we'll expand it. Okay, so write it twice. And go through a FOIL or distribution process. So we'd have 4, and then 2x plus another 2x would give us, 2 tangent plus another 2 tangent would give us a 4 tangent x. And then we have a tangent squared. All right. Can we easily find the antiderivative of 4? Yep. What about, can we easily find the antiderivative of 4 tangent? Actually, if you do, I'd be pleasantly surprised. But unfortunately, well, if you think about your trig derivatives, there's nothing you can take the derivative of that would give you just tangent. Like it was secant tangent, I think, one of them. So this one might be a little tricky. We're going to have to think about this one. Maybe we'll pull the 4 out if you wanted to. Okay, it's a coefficient. Tangent squared. I mean, if we can't easily find antiderivative of tangent, probably tangent squared's out there too. Should have a dx there. Okay. No calculator, okay?
I thought it was a cheeseburger.
I wouldn't mind a cheeseburger right now. All right, let's go ahead and think about working backwards or finding an antiderivative of tangent. Can we be strategic and maybe rewrite tangent somehow? Yeah? Let's try that. Okay, so we can rewrite tangent as sine of x over cosine x. So, can we think about going backwards or an antiderivative with that fraction? Yeah. What do you want to let u be? Cosine. So du, derivative, would be negative sine. If we rewrite it, sine of x over u, and then solving for dx, we would have du over negative sine. Notice how the signs will cancel, which is perfect. So we're left with the integral of negative 1 over u and then du. Can we work backwards from negative 1 over u? Yeah. All right, negative natural log of u, and then maybe we'll replace the u with the cosine of x. Okay, so the antiderivative of tangent is actually negative natural log of cosine. Okay, so that we don't lose focus here, we have the 4x out front. We initially had 4 times this integral, so we would need 4 times the antiderivative we found, which would give us -4 natural log of cosine of x. All right, and we still have to find the antiderivative of tangent squared. So let's go ahead and focus on that antiderivative. Not quite going to work out the same in this case because it's a tangent squared. Maybe we can use one of the identities to help us. Can we rewrite tangent squared somehow? Good, Eric?
Secant squared minus 1.
All right, so notice how in one of the Pythagorean theorem ones, or the Pythagorean identity, it says tangent squared plus 1. You can subtract the 1 over to get the tangent squared by itself. So we can rewrite that integral as secant squared minus 1. So let's see if we can easily work backwards from this. What is the antiderivative of secant squared? What can you take the derivative of that would give you secant squared? Yeah.
I want to say
You would want to say it right. Good. Okay. Tangent, yep. And then let's easily work backwards from 1. That would just give us x. So we would have plus tangent x minus x. We don't know any bounds, so you can do plus c. If you wanted to combine the 4x minus x to write a 3x, you could do that. Okay, but maybe we'll just leave it like that. Okay, so mixture there. We had to do u sub, we had to use some trig identities. Either case, you just keep chipping away until something works. All right, let's try the next one. Sine cubed. Now, if you think about our identities, I don't see any cubed up there, so maybe we can rewrite this somehow. Yeah? Okay, so we know we have 3 sines. We can easily break that up into sine squared times sine. So maybe that might help us use an identity. So we got to think about, now that we have a sine squared, maybe we can rewrite that somehow. And this is when it's kind of the guessing game. Okay, if one thing doesn't work or it's becoming too difficult, maybe abandon ship and go back to the different option. So you got to take a look. How might you want to rewrite sine squared? What do you want to do, Eric? You want to try that one? Okay, we'll do the Pythagorean. Okay. Let's see, maybe we want to distribute in the sine. Can we easily work backwards from sine? Yep, that'd be negative cosine. And then we need to subtract the antiderivative of the next piece. So I'm going to go ahead and write in minus there. How might we take the antiderivative of cosine squared times sine? We do have a cosine squared, so maybe we can use an identity. Maybe you want to try a different technique. U sub, partial fractions, by parts. You got to think of what might be useful here. Yeah? Why? Or how would you want to do that? So what would you choose as dv? Why that one? If you think about detail, right? We don't have any exponentials, so then we would go on to trig, but aren't those both trig?
Yes, but wouldn't it be before since it doesn't have, like it's not power?
Not necessarily. They're both technically trig, so I don't know how you'd be able to choose which one. Does that make sense? Okay, so by parts is when you have 2 different functions, like one exponential, one trig, something like that. Both of these are trig. What do you want to let u be?
Sine of x.
What's kind of on the inside of something? Yeah?
I'm pretty used cosine.
Okay, so this is what's tricky. I know we write it as cosine with that little 2 there, but that means this. Cosine of x squared. Okay, so we can let cosine be the inside part. That's technically what's being squared. So derivative would give us negative sine. If we rewrote that integral, we would have u squared sine of x, and solving for dx, we'd have du over negative sine, which is perfect because the signs would cancel. So can we work backwards from negative u squared? We'd have negative 1/3 u, which we said was cosine of x, and we would need that cubed. So if this is our antiderivative from the second term, we have to subtract that quantity. So if we're subtracting a negative, that would change to a plus. And we don't know the bounds, so plus c. All right. Let's try the last one. Anything you guys feel like doing? Yeah?
Using the double angle from negative to cosine squared.
So you want to use the double angle? Okay, so yesterday we said that was, let's see, solving, we'd have cosine of 2x, okay, double the angle that's in there, plus 1 all over 2. That's just if we rewrote cosine squared. And that's still all over 1 plus sine. All right, so we have a multitude of fractions there. Instead of dividing by 1 or 1 plus sine, we could multiply by the reciprocal of that. So let's see, cosine of 2x plus 1 all over 2 plus 2 sine of x if we multiply the denominators together. Where do you want to go from there?
Do partial fractions.
Can't, oh, I wonder if we can't, because you can factor the denominator, right?
Yeah.
This would,
That might not be easy, but I'm just saying.
you were thinking of it, okay. Right, you could factor the denominator, pull a 2 out, those would be your factors. So we have A and B. I'm curious, I don't know, okay, let's actually just do this on the board, because I didn't do it this way, I'm curious if it would work out, okay? So, let's see, if we wrote this out, we'd have A times 1 plus sine of x plus B times 2. Do you know what? I don't know if we're going to be able to do this because can you strategically pick an x value that would cancel out b? No, because there's no variable in there, right? Okay, so even though we could factor the denominator, partial fractions might not work out, but that was a really, really good shot. Can we try anything else? Let's see, if we tried u sub, again, don't write it down, we're just gonna see what happens here. U sub, we typically let the denominator be that. If we did the derivative, that'd be 2 cosine of x. But notice how that's not showing up somewhere else that would eventually cancel like we want it to. So U substitution might not work. We can't do by parts because we're not multiplying two different functions together. We said partial fractions may have worked, but we couldn't cancel out the b. Abandon ship. Try something else. Okay, so back to the drawing board. Can we use a different identity besides the double angle? Worth a shot, but it didn't work. Try something else. Is there another way we can rewrite cosine squared? Yeah?
1 minus sine squared.
1 minus sine squared, okay. The Pythagorean. Anything else we can do? Maybe? Yeah?
We do difference of squares.
It is, yes, we can factor, all right. Difference of squares. 1's a perfect square, sine squared's a perfect square. So one factor is subtracting those perfect squares. The other one's adding. Anything gonna happen? Yep. 1 plus sine goes away. All right. Backwards from 1, antiderivative. We got x. Backwards from sine. Negative cosine, but you need to subtract that. So that would change to a plus. And we don't know the bounds. There we go. All right. So practice, practice, practice. Okay. Go ahead and try some of the homework ones. If we want to do some together, just let me know. We can definitely do that. But if something doesn't work, go back to the drawing board.